I do. All right, so today we're going down to section 3.5. So we went from 3.3 to 3.5, which makes all the sense in the world. We're going to find the zeros of polynomial functions. That's section 3.5 in general. Section 3.5 is not a one-day section by any stretch of the imagination. We're looking at minimum 3 days to get through this. That's minimum. Yeah, some years it takes 4. Some years it takes more. I don't think you've ever gone more than 4. But whatever. So today, we've kind of been breaking this up into baby pieces as we've gone along, but this section is the one, this chapter, this along with 3.6, kind of brings everything we started about talking about together. We said our whole end goal as we got to these was to be able to factor polynomials and graph them. Everything we've done up till this point has been leading us into where we're at today. And being able to factor them, find zeros to graph them. So today, we're going to identify the zeros of a function by factoring or using synthetic division. That's kind of the second thing we're going to do. And then we're going to use the zeros of a polynomial function to sketch the graph. Okay, so all of those things are going to be done. What order I do them in, I guess I know it's not that one. All right, so first question is this. It's something we've talked about before. So what are the zeros of a function? So if I give you the function that's already factored, which is going to be the first half of today, they're already going to be factored. What are the zeros of that function? Okay, so in your notes, write down f of x equals x times x minus 3 times x plus 4 times x minus 6. With your neighbor, you've got 27.5 seconds after you've got the problem written down to find the zeros. Go. I can eat a piece of my sandwich. I can eat lunch now.
Yeah, so what did you get?
3.
What did you say, Jim?
I don't.
27.5 seconds is up. What are my zeros? 3, 4, I think negative 4. So we got, we need to erase this. Go away. So we've got 3, negative 4, and 6. Is there another one? And 0 is 1 as well. Okay. Remember what it means when we did this, when we did with quadratics. Okay, we used that zero product property. That zero product property said if you have a times b equal to 0, either a has to equal 0 or b has to equal 0. Well, the zero product property still holds for this. Each of these has to equal 0. Okay, so now we kind of have it set that x is equal to 0, x minus 3 is equal to 0, x plus 4 is equal to 0, and x minus 6 is equal to 0. This is the math behind it. That's the zero product property. Do I expect you to write this down every time? No, I don't. I expect you guys, especially 90% of the time, to be able to go to right there. You should be. Caution when you're going there. Going directly there sometimes. What happens is what happened here. Everybody forgets this one. Okay, that still has to equal 0. That's one of your zeros. Second thing that happens is if I have something going on in here, I have like x squared minus 9 in here, then you almost need to set that equal to 0 to help yourself do it. If the answer is obvious, don't worry about it. Just put the solution down. if the answer is not obvious, which you'll see as the next one we do, sometimes it's helpful not to do that. Now, remember what it means to be a zero. Okay, what it means to be a zero is that our graph of this, if I distributed and put all of this out and you were asked to graph this, essentially what it means is that your graph is going to cross at 0, it's going to cross at 3, it's going to cross at -4, and it's going to cross at 6. That's what it means by finding the zeros. And these are considered to be our real zeros, okay? Numbers that we can actually graph on the x-axis, okay? So those are considered to be the zeros and what the sketch of the graph would look like. Okay, so now let's do the same thing for this. What are the zeros of f of x is equal to x times x minus 2 times x plus 3 times x minus 4 squared? So what are my zeros? 0, 2, -3, and 4. Okay, so I guess I didn't do it on that. But those are my zeros. Those are my zeros. Next question I have, okay, so we'll come to the graph and agree. We've talked about degree in the past. What degree is that? What degree is that? So you know we see x cubed, we see x to the 4th, we see x to the 6th. This is going to be x to the what? So if I distribute, so if we think about, okay, obviously it's a question that you're trying to think, okay, how would I answer this? Okay, so let's think about it logically. I have to distribute this into here, right? So if I distribute this into here, it's x to the 2nd power, right? So x times x is x squared. But then I have to take, now it's this thing, and I have to take it into here. So then it becomes x to the 3rd power, right? How many of these are here? There's actually 2 of these here, right? How many x's do we have? 1, 2, 3, 4, 5. So actually the degree of this is 5. Okay? The degree of this is 5, and that's going to become important in just a minute. But again, our zeros are at 0, 2, -3, and 4. So that's when it has to cross the x-axis. Now, how many times does it cross 0? It just crosses it once. It just crosses 2 once. It just crosses -3 twice. But what does it do with 4? How many times does 4 occur? 4 actually occurs 2 times. Because this is squared, remember what it means when it's squared? That I could rewrite this instead of like that. I could write this as x minus 4 times x minus 4. So actually that occurs twice. And that has something we call it. We call that multiplicity.
Oh my God.
Do not write all of this down. That's too much to write. Don't write this down. Just listen. The multiplicity of a zero of a polynomial is the number of times its relative factor appears in the factored form of the polynomial. We call it its multiplicity. Essentially, all of that means is that multiplicity is the number of times that 0 occurs. All that says. Okay, so if we go back to the previous example and we talk about multiplicity, if I go back to this one, you heard me say 0 occurs once. There's only one time that the answer is 0. So 0 has a multiplicity of 1. 2 only occurs right here, so it has a multiplicity of 1. -3 only happens once. But 4, it happens twice. So 4 has a multiplicity of 2. Okay? And that's what multiplicity is. It's the number of times that that 0 occurs. Now, that's important because of this. When the multiplicity is odd, and this needs to be in your notes. When the multiplicity of a 0 is odd, the function itself crosses the x-axis. So if it's 1, if it's 3, if it's 5, if it's 7, that means that when you graph it, so say I've got a 0 that's sitting right there, and my graph is going in this direction. If it's odd, it's going to go right through that point. Now, it might turn and come back up this way somewhere down here, or somewhere way down here, but it's going to go straight through it. If the multiplicity is even, the graph has a turning point at the x value. So odd, it goes through or crosses the x-axis. Multiplicity is even, the graph has a turning point at the x-axis. Well, turning point, that's a mathematical term, of course. Use Enertson terms instead of mathematical terms. It's going to bounce off it. So the graph is going to bounce off that 0 if it has a multiplicity that's even. It just bounces off of it. That's called a turning point. So that's a turning point. We're not going to worry about how to find that turning point. But this one we are. Okay? So that multiplicity is needed to figure out what our graph is going to do. Is it going to go through the point, or is it going to turn / bounce off of it? So if I look at this next one, f of x is equal to x times x plus 4 times x minus 1 to the 4th power. The first thing we want to do when we start to graph these is we want to find the zeros first. Has to be the first thing that you do. That's why we started with it. So the zeros for this are 0, -4, and 1. 0, -4, and 1. Those are my zeros. So I've got 3 zeros. Now my multiplicity. Too long to write, so I'm just going to write it. Mult. How many times does 0 occur? Once. So it has a multiplicity of 1. -4, how many times does it occur? Once. So it has a multiplicity of 1. How many times does 1 occur? 4. 1 occurs 4 times, so it has a multiplicity of 4. Okay. What degree is this one? Say it. You said it. 6. Multiplicity of this is 6. There's 1, 2, 3, 4, 5, 6. What else do you notice? 1, 2, 3, 4, 5, 6. Do I have to do it like that all the time? What do those add up to? The multiplicity adds up to the degrees as well. Okay, so we can say that this is a 6th degree. So this has a degree of 6. What's the leading coefficient? Is it positive or negative? It's positive. Is there any negative symbols before any of them? No. The leading coefficient is going to be positive. Why am I asking that question, do you suppose? What did we use the degree and the leading coefficient for? Back to your other last test. The endpoints. Okay, so we talked about the endpoints. Okay, so if we're going to graph these, I need to know where they're going to cross the x-axis. That's our zeros. Okay? I need to know what the endpoints look like. I need to know where it starts and where it finishes. Not real words, but I need to know where the endpoints are. Start and finishes make sense in your language. Mathematically, it's the endpoints. Who knows where it starts? Who knows where it ends? Which way it's going. Okay? So remember our 4 that we had. Kind of side notes. Might not need this. You might need it, but just a reminder. If the degree is even, and the leading coefficient is positive, We're in those two spots. If the degree is even and the leading coefficient is negative, the end behaviors are here and here. That's where they have to be done. If the degree is odd and the leading coefficient is positive, it's here and here. And if the degree is odd and the leading coefficient is negative, it's there and there. So those are ending behaviors. And again, that was in our last assessment. Some of you did very well with that. Some of you didn't do very well with that. So there's your refresh on how to do that. Okay, so now let's take it back to this here. Now let's graph it. So if I'm going to graph this, I know where my zeros are. My zeros are at 0, -4, and 1. That's where my zeros are. It's a 6th-degree polynomial with a leading coefficient that is positive. So it's even and positive, which is this one. So my end behaviors are going to be here and here. They have to be. So now if I start to graph this, this is the point, and obviously this is -4, this is 0, and this is 1. It's going to come down to -4. -4 has a multiplicity of 1, so its multiplicity is odd. So does it go through it or does it bounce off it? Goes through it. Somewhere down here, it's going to have a turning point. Where that turning point is, we're not going to worry about. It's a relative max. It's called a relative max or a relative min. And we're not going to worry about it in this class. That's going to be a pre-calc piece of it. Note that it doesn't go in the middle all the time. Sometimes it does, but not always. So it's going to come up now. It's going to hit 0. Does it go through 0 or does it bounce off it? Goes through it. Up in here somewhere, it's going to take a turn, and it's going to come down towards 1. But when it gets to 1, is it going to bounce off of it or go through it? It's going to bounce off of it. Does it go in the directions that we want it to go? Are the end behaviors correct? Yeah. So you can check these to make sure you're kind of right anyway. Okay. That's not what this looks like, but sort of. Okay. Questions with that one? What's that? Let's look at the next one. Okay, here's what I want you to do with this one. I want you to find the zeros. I want you to find the multiplicity. I want you to find the end behaviors, and then I want you to stop. Don't graph it. We'll graph it together. Okay. So find the zeros. Be careful with the zeros. Find the multiplicity and graph, and don't graph it. And the degree. Find the endpoint. Do not graph this. And looking at the first one, you should figure out why you shouldn't graph this. Because where the heck is that at? Again, remember what it means to be a zero. Give you about a minute. Go. Give me another chance to eat. All right, here we go. Now, first one you have to be careful with. Okay. What's the answer? Positive and negative 3i. So remember what it means to find the zeros. You have to set that equal to 0. Okay, so we subtract 9 from both sides. So x squared equals negative 9. So remember when you take the square root, it has to be positive or negative. 3i. Do you have any idea where to graph that? No, I don't either. This one's straightforward. It's just 1, right? And this is negative 2. So our zeros are 3i, negative 3i, 1, and negative 2. Multiplicity-wise, how many times does 3i happen? 3i happens once. How many times does negative 3i happen? It happens once. How many times does 1 happen? 5. And how many times does negative 2 happen? 2. So what's the degree of this? Okay, so the degree of this is 9. Leading coefficient is just going to be 1. So it's odd and positive. So odd and positive are here and here. Now, because of the 3i and negative 3i, I'm not going to have you graph this one. And if you get an I or a 3i inside of your homework assignment today, I didn't mean to, but it happened, don't graph that one. Okay, this graph actually looks like this. This is what this graph looks like. And if you widen it out, you can't even see it. There's that turning point because negative 2 happened twice. There's that turning point right there, how narrow that is. And it goes down, 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 way down there. And then there's. So there's a lot going on with this graph. So today, if you get I's and 3i's, don't graph them. Just skip that one and go to the next one. Can we find the zeros? Can we do all of these things if we have to? Okay, we're not even close to done. I'm sorry, this is a long lesson. Okay? So in general terms, this is how we sketch the graphs. First step is you always find the zeros. Whether it's given to you because they're in factored form, or, like we're going to do next, you have to factor them. The first thing you have to do when you're sketching the graph is find the zeros. Once you find the zeros, list the multiplicity. After you've got that, figure out what your end behavior is by finding out what degree it is and if the leading coefficient is positive and negative. And not till then are you ready to do the sketch of the graph. Okay? And it has to kind of be done in this order. Could you do the end behaviors? Yes, you could do that right away, depending on what it looks like. If it's in factored form already, do it in this order. If it's not factored already, you can do the end behavior right away. But this is how we go about graphing them. Okay? Now, everything I've given you up till this point has been factored. Okay, it's in factored form. And that's how the first few on your assignment today are going to be. But what happens if... Oh, look at that. Do you need to try one or are we good? Okay, so let's just go to this. What happens if it's not in factored form? What if we have to factor it out? Well, we got factored. Okay, so we're going to find all the zeros and sketch the graph. But today, you are going to be given one of the zeros. So I'm going to give you one of them. We just have to factor it to find the rest. Okay, so what this question says, it says our function f of x is equal to x cubed minus 9x squared plus 26x minus 24. I'm giving you one of the zeros. X is equal to 2. That's one of the zeros. Okay, so that 0 is 2. What does that mean my factor is? If 2 is my 0, what's my factor? X what? X minus 2. So one of my factors of this is x minus 2. Okay, so if one of my factors of this is x minus 2, I have to find the rest of the factor. Okay, I've got x minus 2, But something has to go right here. I got to put something there. How? Think about what we've done. Say it, because that's right. Everybody needs to hear it.
Oh, synthetic division.
Okay, so you're going to use synthetic division, and if I use synthetic division, what should happen? Anybody can answer that one. What should happen at the end? What should the remainder be? 0. So if I use synthetic division, the remainder at the end should be 0. But then what did we do with the rest of that stuff? We turned it into a different polynomial, right? So let's do synthetic division on this. What goes inside of the box? 2 goes inside of the box because that's what my x is equal to. It's what my 0 is. Now we just take the leading coefficients. So my leading coefficients are 1, -9, 26, and -24. Now we've been told that this is a factor of it, that this is a 0 of it. So my end result over here better be 0. If it's not 0, you've done something wrong along the way. Okay, so if we check it out, we've got a 1, gives me 2, -7, -14, 12, 24, and 0. Yay. Okay, so it is a factor of it. So my first factor of this, I know is x minus 2. What's my other factor? How do I write this? Not -7. We got to start with just 1. So we start with x squared minus 7x plus 12. Okay, now I've run out of room, of course. So we've got that, but I got to find the zeros. I know one of the zeros is 2, but that also means then I have to set this x squared minus 7x plus 12 equal to 0 as well. So I've got a quadratic that's equal to 0. Got 3 choices. Quadratic formula, completing the square, or factoring it. Try factoring first always. If factoring doesn't work, then use the quadratic formula. But try factoring first. You guys should be getting pretty good at factoring that. So, kind of a side note, that's the x method. 12 and -7. So, -3 and -4. So my factored form for this, I need more room. I don't have it. So it's x minus 2 times x minus 3 times x minus 4. That's my factored form. Okay, so I'm going to try to see if I can do this. Copy. Add. Paste. Oh, it kind of worked. Good enough. Okay, so those are my zeros. Or those are my factors. So my zeros are 2, 3, and 4. Does that look right? Is that what we had? Okay. So what's the multiplicity? 1, 1, and 1, 1, and 1. So we found the zeros. We found the multiplicity. Degree. What degree is it? Third. So it's a third degree. So it's odd and positive. So we're going to start to sketch the graph. So odd and positive is the third quadrant and the first quadrant. My zeros are at 2, 3, and 4. They're all multiplicities of 1, so they just go through it. So that's what your graph for that one should look like. Okay. So it does become a bit of a process, but it's a process that you've done. Okay, you've got to think about this piece as being one of my factors. Use synthetic division to figure out what your other factor is. Get it in factored form. Find the zeros. Multiplicity, degree, graph. Try it on your own. X cubed minus 4x squared plus x plus 6. I wrote it like this because this is how your book does it. The 0 is 3. It's not how your book does it. It's how the worksheet that you get today does it. The 0 is 3. I know this is a long lesson. I apologize. Find the zeros. Sketch graph. Ouch. Are you going to make it? All right, solution is up there. Yeah, you did. So there's the sketch. There's what the actual graph looks like. Questions with that? All right, so today what you're going to do is you're going to get practice kind of on this style. And you should be able to see kind of where this is going to go over the next couple days. Tomorrow we're going to take away we're going to take away the 0. Right? And we're going to have to find the 0 ourselves. And that'll be tomorrow. Tomorrow we'll just have a leading coefficient of 1 out here. Then we'll change it so the leading coefficient isn't 1 anymore. We can do it that way. Okay, so we're just going to kind of keep building on this as we finish things off. Okay? Today, don't do question number 4. First, don't do question number 4. Second, if you have an I in your zeros, don't graph that one. Skip that one. I think it's only 1, but it might not be. I don't know. I do know all the ones that you have to factor don't have that. Okay? Sorry, I know it was long.